Hi, my name is Heather Russell, and I'm an assistant professor in the Department of Physics and Astronomy. My research centers around discovering the fundamental nature of our universe. What are we made of at the smallest level? The way we do that is by colliding protons, that is, the nuclei of hydrogen atoms, at super fast speeds at the Large Hadron Collider in Geneva, Switzerland. Now, when we collide these protons, most of the time nothing interesting happens. They're just like balls, they bounce off each other elastically. So in order to actually study particle interactions we get at the most fundamental level, we need to collide lots of them. And when I mean lots of them, I mean we collide like 10 billion protons with 10 billion protons all bunched super tight together 40 million times per second. Now, you can imagine this might give us a lot of data. So what we want to do is record the output of all of these collisions when interesting things happen as frequently as we can, and then we'll collect a massive data set to analyze. Then, when we have all these collisions, all of this data, and we're not talking about data that can fit on your laptop here. We're talking about data that fills data centers, more data than Facebook had. And then what we do is we need to analyze it. So we need a lot of computers, a lot of computational power to be able to analyze this. And this is where things like massive research clusters come in. Can't analyze on your laptop, but you can send a little job off to the massive research clusters, and it'll analyze the data and send back the output. And that's how we look in these massive data sets for new particles like the Higgs boson, which we discovered in 2012, or perhaps hints of dark matter particles that explain why galaxies aren't rotating at exactly the rates we think they are, or we see they are.